Hello world and welcome back to another Immersive Engineering tutorial where today we're talking all about power. When it comes to power, there are many things involved, such as generating it, storing it, transferring it, and even using different voltages when it comes to immersive engineering. Today we're going to be covering 3 different ways of creating basic power, and the first 2 are all going to be using this Kinetic Dynomo. However, in order to create this Kinetic Dynomo, we must start at the beginning, and that is by making plates. Essentially, the first thing we're going to need is that copper coil. Now, in order to make a copper coil, we're first going to need some plates, which means we're going to need one piece of copper and our hammer, which we created in the previous episode as a basic tool. Inside of a crafting table or inside your crafting table in your inventory, you can make 1 plate from 1 copper. Very, very simple stuff. Then, using your wire cutters, you can now snip up this wire plate into a piece of copper wire. Unfortunately, it's only 1-to-1, so basically 1 copper gets you 1 piece of copper wire. You're then going to need 4 pieces of this copper wire and a stick in order to make this LV wire coil, and you'll get 4 of these from that craft. Now, a couple of things about this wire coil: you're also going to use it to actually wire up all your electricity around your base. Now, these wire cables, they can actually only travel up to 16 blocks in length. That is just for the LV. As you go up higher in voltage, they will go a little bit further. As well as that, these cables will actually lose power over time at a maximum of 5% if you go the full 16 blocks away from your start point. As well as that, LV wire coil can transfer up to 2048 RF per tick before it actually burns out. Now, you'll find out what I mean by burning out later on. Next up, to make this copper coil block, we're going to need 8 of these LV wire coils and a piece of iron in the center to get ourselves a block. We'll only get 1 of these, and then using this copper wire block, you'll also need 3 iron along the bottom and 2 redstone dust in order to make your Kinetic Dynomo. Now, you're going to need at least 1 of these for either one of these next power generation devices. So to create power, as I say, there's going to be 3 different ways of making power at this level. One's going to be a water wheel, one's going to be a windmill, and the last one's going to be a little bit more complicated, and that's the thermoelectric generator. So first, let's go over the water wheel. The water wheel and the windmill are both completely made out of treated wood, and we discussed how to make treated wood out of creosote oil in the first episode. Now, you're going to need to take this treated wood. 2 planks are going to give you 6, just like you would in vanilla, and you actually still get 4 of these. Next, you're going to take some even more treated wood planks and some treated wood sticks, get 4 sticks and 3 wood to make these water wheel segments, as you can see here. You're then going to need 4 of these water wheeled segments and a piece of steel. Steel you get from the blast furnace, as we showed before. Just check out the previous episode. And then you'll get yourselves a water wheel. As you can see here, you only get 1. Now, the water wheel, it generates up to 30 RF per tick at a maximum. Now, you see I said per wheel here, and you'll see why I said that shortly. Next, we're going to be making the windmill. In order to create the windmill, you're going to need windmill blades, of course. This is going to require 4 treated wood sticks and 3 treated wood planks, and you only get 1 of these windmill blades. You're going to need 8 of these windmill blades and a piece of iron in order to make your windmill, as you see here. Now, the windmill works a little bit differently now to previous versions of the mod. Previously, the height of your windmill did matter with how much generation you would get, but in 1.16, that no longer is the case. It all depends mostly on the weather. It depended on the weather before, but it's pretty much just the weather now. If you're in a clear day like we have here, you will be able to get 35.55 RF per tick, and if it's raining, you'll get 47.4 RF per tick, and if it's a thundery storm, you'll get 71.82 RF per tick, so you want them thunderstorms. Now, you may notice that up there I have got a windmill, but it doesn't look like it does in its icon. There are none of these white little blades around it, and that is the same when it's actually in your inventory. It's not a bug, but it just is that way. Now, in order to actually get these white little things around the side, they're actually called sails, and you need to make them with industrial hemp. Industrial hemp, we know, is grown, as we showed previously. You're going to need 8 of these industrial hemp fibers and a stick in order to create a tough fabric. The tough fabric is actually used for things later on that we're going to show when it comes to wires, as well as other things. We're then going to take this tough fabric, we're going to need 6 of them in total in order to make a windmill sail as shown here, and you only get 1 of them. And in order to fully cover your windmill with sails, you're obviously going to need 8 sails, 1 for each blade from your craft. Now the last way of making basic power is by using the thermoelectric generator. This is going to require 3 steel, 1 more of those copper core blocks, and this time 5 constant tan plates. Constant tans you make in an alloy kiln, and then you obviously turn those ingots into plates using the hammer. Now the thermoelectric generator will generate a maximum of 42 RF per tick, which is pretty good. However, this is by using some pretty advanced blocks in order to do it, but we'll explain that more shortly. Now you can actually get more out of this block, but we are showing obviously just using vanilla Minecraft and Immersive Engineering. We're not going to be showing any other things from say thermal expansion or anything. So just using vanilla and Immersive Engineering, you will get 42 at a maximum. Now before we actually show off how you can use these tools to make power, we first need to know how to actually move power around and store the energy, which is where we're going to come into capacitors, connectors, and we're even going to show off how the transformer works when switching between voltages. First off, we have the LV capacitor. Capacitors are basically batteries in this mod. And now the LV capacitor, that's what we're going to start with, is because that is the basic tier and is using all the LV wires and stuff which we've used previously. Now this is going to require 3 iron ingots, 2 copper ingots, a lead ingot, 1 redstone dust, and 2 treated wood planks, as you can see here, and this can store 100,000 RF in total. In order to get power in and out of this block, you are going to need connectors, and we're going to use LV connectors. The LV connectors are essentially the way of putting in and out power out of either a machine or out of a capacitor. These are created using 3 copper in the center and 4 terracotta around the bottom 2 layers, as you see here, and you get 4 of them in total. These connectors are possible of transferring 256 RF per tick through a wire. Now we mentioned earlier that you can only transfer a wire 16 blocks away from where it begins. So if I place down this connector here and I right click on this connector, we now have linked our wire to this connector, and we can now travel up to 16 blocks away before our words are going to go red and we have to click it on another connector. So if I start walking away here, we'll see that eventually all these letterings are going to turn red. That means if we tried to place our connection over here, it would not work. Let's see, if we place this here, just as a demonstration, see, you're too far away to the previous connections, you see. So what we can do is if we go ahead, we'd right click there, let's go for a little bit closer here, and we press it down here. Now, as you can see, it didn't actually connect again. And that is because wires in Immersive Engineering can't pass through blocks. So if we have to break through these blocks just here and then place it down again, this time it's going to work because now the wires aren't going to be interfered. Now, as well as that, if you place a block in here afterwards, the wire will just pop off. In previous versions, you could place down blocks afterwards. So for now, let's just raise this off the ground for ease of use. So what if we want to actually go further than the 16 blocks that we have here? This is where a LV relay gets involved. This is a way of extending your power line. You cannot use a relay to input or output energy like you can a connector, but it works as just extending your line as said. This is crafted with 2 copper ingots and 2 terracotta, and you actually get 8 of these in total. So now let's demonstrate this. If I get this LV wire, we now want to extend this line. Now something we can do is we could just break our connector here in order to get our wire back, but something we can do is with our engineer wire cutters, if we just right click on our connector, we can see that the LV wire has just popped off, which is very nice. We have to break this anyway for this demonstration, but let's do this here. If we now connect our relay to a connector, we see we have our point here. Now we have to extend this a little bit further. Let's just go over here for argument's sake. If we now take our relay and then our connector, we can place this here, and now we've taken our connection even further. Another really useful thing when it comes to relays is that relays can actually connect to other relays. You see, LV connectors and other type of connectors, they can only connect to one other source. So if I tried to connect this, say, LV connector over here to this relay, it wouldn't actually work. You see, you cannot attach this wire here. It just does not even let you to begin with. You connect to this one, but then you cannot connect your wire to the connectors. Connectors can only connect to one thing, which is why you need a relay to either split up your power or bring it all down to one line. Also, just to demonstrate again, another bonus of using your cutters on a relay or connector or machine is that when you right click on it, it's actually going to disconnect every wire, not just one. Now, the last thing to know when it comes to wires is that these wires are actually going to hurt you if you go near them. Now, this is just low voltage, so luckily it doesn't actually damage you too much, but it also depends on how much voltage is actually going through the wire. The higher the voltage, the more chance it's probably going to kill you. Now, there is a way of actually insulating this wire. We're dealing with LV cable, so you can get insulated LV cable. You can also get insulated MV cable, which is medium voltage. However, you cannot get insulated HV volume wire, which is high voltage. We'll talk more about insulated wire later on. For now, here is our water wheel. Now, you see on this water wheel, I actually have 3 different water wheels in total. That's because to one Kinetic Dynomo, you can place 3 wheels on it. And for each different wheel, you will generate 30 RF per tick, provided that enough water is making it spin round. To get the max amount of RF out of your water wheel, you are going to need some flowing water, and it must touch the water wheel in 13 different places. Now, the water must be flowing, they cannot be source blocks. It does not have to be in this direction. As you can see, this is going anti-clockwise. It can flow the other way and go clockwise. It depends on how you want to do it. Now, I have here 3 different source blocks at the back here, and it's just flowing down. I just made this frame as the best way to do it. You can obviously do it into a mountain, or you could just have it on the floor. Now, what I've done here is I have reduced the amount of water flowing in the water wheel, and as you can see, it's flowing a heck of a lot less than it was before. This is now going to be generating a lot less energy. So if you want the maximum, make sure you keep it all the way up to your 13 different blocks. I always do this frame, and I recommend it's the best way of doing it. That way you can place it anywhere. It looks a bit finicky, but it works. When it comes to placing down the water wheel, you're first going to have to place your dynamo. Your dynamo is going to have this black circle on the face that is towards you. That is where you place your water wheel. As you can see, I have it raised up because if we try and place this water wheel down here, I'm right clicking right now, it does not work. It must be raised up in the air first, just like this. 4 blocks up is the best for me on the 4th block. Then on the dynamo, on the back of it, there is this little sort of button here, and at the top, these are your power output points. This is where you put your connectors in order to send them on. This is what we have here. We have an LV connector right on the back here, and it's being connected to another LV connector, which is now on a battery. Now, the capacitors, when they place it down, they're a little bit finicky. When you place it down, they are going to be blank on all sides except from the top, and the top is going to be an input. If you don't know, Immersive Engineering, blue means input, orange means output. Now, we can set these sides. If we take out our hammer, we can now see on the side we're facing, it will tell you our connections, both on the side that's facing up and the opposite side of the block. You see on this side, there's no connection either side, and if we look at the top, the facing side is now energy inputs, as we've already discussed. So that is how we've got this set up. We've got our energy coming out the dynamo and into the top of here, which is giving our energy input. But now what if we want to actually get our power out? Well, we can simply do this by right clicking on the side. We see we have energy input, now energy output because it's turned orange, and then we can click it one more time for no connection. And we can do this on any single side that we would like. It does not matter. Now, as you can see as well, we have opposite side. If we wanted to actually place down our output to be on the underside of this block, there's no way of us doing without breaking the block. There's 2 ways we could actually do this. The easiest way is by looking at the top, holding shift, and now doing the right clicking. As you can see, that changes the opposite side. So if we wanted output on the other side, we now have the output. So let's just do this on the side of the block for a demonstration. If we right click now, we now have on this side energy input. If we do it again, we now have on this side energy input. Another thing you can actually do if you want to do something in advance is if you place down a block, you could then change your side just by looking at it to energy output. Then we could actually break the block and place it down somewhere else, and these will actually keep the settings. All the capacitors in this will actually keep their settings, which is a very, very handy way of moving things around. So this is great that we have this set up, but how do we know if this is actually being powered? We see that the tooltip at the top doesn't actually tell us how much power is in this, and if we right click on the battery, it doesn't actually give us an interface. This is where the voltmeter gets involved. The voltmeter is a handheld device that will tell us how much energy is inside of a battery or even a connector. We make this with a compass, 1 copper ingot and 2 sticks, you can see here, and you'll get 1 engineer's voltmeter. If you hold this in your hand and then look over a capacitor, it tells you how much energy is stored out of how much it can totally store. As you can see, with an LV capacitor, we can hold 100,000 RF. Then if we look in a connector, we can do it there as well. As we know, a connector can transfer 256 flux in total, which is why we have that as a max energy store. Now, we discussed earlier how you actually lose power over distance. That is something the voltmeter can actually test. If we hold shift and right click on this connector, it says we're linking, similarly when we were actually placing down our wires. Now, if we right click on the next connection, we can see that at this distance, we are losing 0.625 of our energy over this distance. There's not a lot, it's pretty much negligible, but there is a loss. Moving on, we have a windmill. As you can see, it's high up in the sky, but this isn't the best it could be. Placing it up or down further in the sky will not actually have an effect any longer, but there is a way to make this faster, and that is obviously by using those windmill sails that we said. To apply these windmill sails, you actually have to do it physically in the world, so you have to place down your windmill on a kinetic dynamo the exact same way as the windmill, and then take your sails and just right click on the center. You're going to have to do it 8 times to fill them all up, and now you can see that's noticeably faster. Everything else here is linked up the exact same way as with the windmill. We've got a connector coming out the back of the dynamo and straight into a battery, and we can see with the voltmeter how much is stored. It's 100%. But the only difference we have here is that this is a lot more of a distance. So how about we see what the percentage lost is over this distance now? 3.125%. That's quite a lot more of a loss. And obviously, if we had this connected to a relay first and then into our block, maybe stretching all the way over there and then back, we'd lose even more energy over time. So you want to keep all your energy sources pretty close together in the basic starting, because you're not going to be generating too much in the beginning. Now, the last basic form of power generation is going to be the thermoelectric generator. This is going to require a little bit more of a setup, and as you can see, we have multiple blocks. Now, the way these thermo generators work is that when you place it down, we have your output at the top. Nothing on the side of this can actually be changed. If you right click on the side of the hammer, nothing is changed. It's not like a battery. But the way this generates power is the difference in temperature either side of the block. Now, when you first start using these, you're probably going to be doing something like this. You see we have lava on one side and water on the other. Lava's our hot side, water's our cool side. So the difference between these two temperatures is what the energy is going to be created. I'm going to throw up a little graph here to show you, or a little table here, of what the different temperatures are. You will notice that there are some things in this graph that are from other mods, but don't pay attention to them. Basically, the best thing you can do when it comes to these in base vanilla Minecraft and Immersive Engineering is using blue ice, which is vanilla Minecraft, and a block of uranium from Immersive Engineering. This is going to give us our maximum of 42 RF per tick. And the way this is calculated is that one side, this block over here and this block over here, that gives us 21. If we then utilize the other side, we then get 42, of course. And this is how we can actually scale this. This is pretty much the only power source where it's scalable. You just basically make a bigger platform. We've got X amount here linked up together to generate our power. Now again, you are going to get different differences in loss over time. If we go from here to here, we can see we get 1.67. If you go from here to here, it's a little bit more, 1.613. So it's a little bit negligible, but obviously you don't want to be growing too far out. Essentially, once you go out a little bit more, you probably want to start going up or down to keep things close together, and it's almost like a large battery array at this point. So how about we delve a little bit more into something more advanced, and this is going to involve us going up a voltage into MV, as well as we're going to use a device to actually read how much current's going through our cables before they actually burn out. First off, we're going to show the transformer. The transformer is going to be able to transform power from MV to LV and back again, so you can transfer LV to MV. This is made using an electrum block. Electrum is pretty much the source of making your cables for MV. MV cable is made just using electrum plates or electrum ingots into plates into wires to then be made into MV wire, same way as copper, and then you can use that to make an electrum copper coil. We're then going to need an MV connector. This is made the exact same way pretty much as the LV connector, except it's using electrum. Same with the medium relays, it's just going to use electrum but made in the exact same way as the LV relays. And then we're going to need an LV connector and 5 pieces of iron, and this is going to give us our transformer. The next device we're going to show is a current transformer. This is essentially a little bit of an upgrade to the engineer's voltmeter as it needs it to craft. We're going to need one of those, we're going to need 2 copper coil blocks, 2 terracotta and 2 more iron to give ourselves our current transformer. In order to demonstrate the difference in voltages, we're going to be using ourselves a diesel generator. We're not going to be covering that today, so subscribe and ring the bell button to get notified when that episode comes out. Now on top of our diesel generator, we have got 3 MV capacitors, and with our voltmeter we'll be able to see that inside these MV capacitors you can actually hold 1 million flux, so a little bit more of an upgrade to the LVs. Now these, we have all 3 of these connected up to an MV relay, and then that MV relay is going into our transformer here. You can tell which side is MV and which side is LV by the connectors on top. Basically the smaller one, that's going to be LV, and the bigger one is going to be MV. Then once we've transformed it, we've got our LV connection going into our current transformer here. This doesn't do anything besides tell us how much current has been going through our flux, going through our system in the last 20 ticks, and then we have it linked up to a relay. Now this is a good point to demonstrate that immersive engineering power can actually power other machines that require RF, such as Mechanism, which is what we're going to be using here. Immersive engineering doesn't have any single sock block machines, which is why we're going to be using Mechanism for this. Now MV connectors can actually transfer power at 1024 RF per tick, which is a little bit better than LV, which is why we need to make sure that we do not overload our LV cable to more than 2048, otherwise our wire will burn out. So if we take our LV connection here and connect it to one machine at a time, and then press right click on this LV transformer, we can see that just connecting this one machine, we're now using 261 flux per tick. Now if we add one at a time, we can see that this number is going to increase rather rapidly, roughly 250 at a time. So once we've actually connected all of these, we're going to see that something bad may happen. Here we're at 1748. If we link up the last machine here, we can see there's a little bit of a flame effect here. We have now overloaded this cable. It overloads from the transformer down to our relay. It doesn't go all the way because it splits here. If only one of these machines ended up sucking out more than 2048 power, it would actually burn all the way to the machine. But all of these are doing about 250 each, so it won't go this far. It will just go to the relay. This is where it's important to use a wire cutter to actually snip off our last machine, so then we can connect things up to make sure that we can actually switch this around and make sure it works effectively. Now you can see that I've got all these machines fully linked up, because there is a way of actually running all these machines at once, and that is at the source. I've disconnected here so things don't burn out. At the source, each of these are obviously going to be chucking out roughly 3000 RF per tick, because that is how much a medium voltage thing actually pulls out. These machines don't actually need that amount of energy, so what we can do is actually remove one of these power sources in order to actually send a good amount of voltage, enough to power it but not enough to burn out your cable. So how about we connect these back up? We can see that everything's burning up now, and if we go back to our current transformer, we see that we're at 2008. We're only 40 from it burning down, but we are now actually still using all the machines we require. They're not getting enough power, but they are all running. Now something else we can do, of course, is by changing the batteries all to LV. That way we're a little bit closer off the margin, but if we right click on here and now attach it, we can see that everything is now running again, and if we right click here, we're only using 748. It's a lot less power, definitely not enough for these machines, but they are running, and that's what matters. Now there's one more thing to be wary about when it comes to actually running wires. What if you have your power source, this being a creative capacitor here, and your power source is outside, you're generating stuff outside, you've got your water wheel, your windmill, it's all outside of course, and you want it inside. Now there is a way of actually transferring your wire through walls, because as we know, if we try and actually place down a wire, it doesn't work, blocks get in the way. The way to do this is by placing down your LV connectors or any type of connectors either side of the block, and then right clicking it with your hammer. You can see that there's now been a little brown tinge around the block. This is because this block has now become its own little multi-block structure. And as you can see here, there's been a little bit of a glitch. I don't know why this is happening, but if you just take your LV wire, you can connect it anyway and it just switches back. It's a bit of a weird glitch, but it seems to be happening. So if we take our voltmeter, we can see that there is nothing inside of our energy storage here. And now if we link it up, we can see that power is now being stored inside of our capacitor. Now you can break these up. You can see that when you hover over this, it's now called a feed-through insulator, and you can break these all individually. And if you broke the block, the two connectors would actually pull off. Now you don't have to worry about the wires being attached first. You can actually have the wires attached and then connect the two together. It gives you this weird glitch sometimes, but it does work. There you go, removing the wires and placing the wires back on can fix the problem. It's a little bit finicky, it might just be the mod pack I'm on. And then earlier I spoke about insulating your wires. To insulate your wires, you just take 4 of the wire that you want to insulate and some more of that tough fabric, which is the same stuff we made our sails for, and inside we can get 4 insulated wire. We're essentially insulating the 4 wires that are in the craft. This doesn't do anything else, it doesn't give you any more power loss or anything like that, but it will stop you from taking damage when you walk into it. As I say, you can get MV insulated wire, but you cannot get HV. Now the last thing I'd like to show off is just something more that's a little bit more aesthetic for running your wires when it comes to making your base, and that is using both wall mounts and posts. You can get different tiers of posts. This is a wooden post, but you can also get steel and aluminium posts, but the wooden post is by using treated wood fences. You can probably guess, but treated wood fences made just the same way as vanilla, but obviously with treated wood, and then you're going to need a stone brick to give you your wooden post. Then to make your wall mount, you're going to need 3 treated wood planks and a treated wood stick to make your wall mount. Now let's cover the wall mounts first. The wall mounts are pretty cool, as when you place them down, they just look like a spot to hold a lantern or something. You can obviously place your connectors on this and run your wires maybe along the wall or something. As well as that, you can place other things on here like a torch or something, whatever you'd like. But something cool about these wall mounts is that you can actually place them similarly like stairs. If you look at the bottom of your block and then right click, you will then have your wall mount but upside down. So if you wanted to run your things along the ceiling or closer to the ceiling, you could do it this way instead. Or maybe do some hanging chain or something, I don't know. I'm sure you could do some decorative stuff with it. And then when it comes to the posts, it's a similar story. You can place your connectors directly onto it or your relays, and you can see that you actually get this little post automatically sticking on it. And this works on all 4 sides. However, something that it only works on is the first 2 pieces of your wooden post here. As you can see, it's made up of 3. The top one doesn't actually work. You can place it, but it doesn't give you your animation. And that is because you must use the hammer in order to get it. Using your hammer, you want to right click on the side and it will pull out a post. And this can be done on all 4 sides, however, not all at the same time. It can only be doing opposites. I'm right clicking here and it's not doing these other 2 sides, sorry. But if I get rid of these, I can now do it on these sides. It's pretty cool. And then of course, you can clearly place your connectors on top and maybe do a whole run, maybe do a low voltage, high voltage, or whatever. Now something later to come is that you can actually get redstone connectors as well and redstone wire, so you can make redstone run between bases as well if you wanted. But more on that in the next episode. Thank you so much for watching, everyone. This is everything when it comes to basic power generation inside of Immersive Engineering. If you did enjoy, please give me a like and subscribe. It really helps me out. And ring the bell button for more immersive tutorials in the future, where next time we're going to be covering a little bit more about basic toolings and your first little machines. But until next time, guys, take care.